Hello friends, now let us learn how to identify redox reaction amidst different chemical reaction. I know you are preparing for jam and you may give a certain different chemical reactions and you may be asked to identify which of the reaction is actually a redox reaction. Now, what do you understand by redox reaction? I believe might have known what that is. A redox reaction, in a redox reaction, there must be an element or an atom that increases from reactant to product and another that decrease from reactant to product. So you must find that in a redox reaction. So there's a couple of things you know. Um, you know before you be able to identify whether an equation is a chemical equation is a redox reaction. Now for this number one, A says um, this is a ethanol plus oxygen gas reacting to give us carbon dioxide plus water. Now it is interesting for you to know that in any chemical reaction that has a pure molecule or a pure atom, it is a redox reaction. I repeat again, any chemical reaction that you see that has pure atom or pure molecule is a redox reaction. What does that mean by pure atom or pure molecule? Oxygen gas is a pure molecule. That is a molecule of oxygen alone, not not combining with any other element. You know, this is also a molecule of water, right? But this is an impure molecule because it's containing oxygen is combining with hydrogen. So this is not a pure molecule. By the time you now take away oxygen here, hydrogen becomes a pure molecule. So a redox reaction must contain either a pure molecule or a pure atom. These pure atoms and these are pure molecules. This can occur to any other diatomic or triatomic elements or atoms too. So using that here, if you look at this chemical reaction, this is a pure molecule, which shows to us that this is actually what? This is actually a redox reaction. So we say that this is a redox reaction. That's the simplest way of identifying a chemical reaction that is redox. When you see that a pure molecule, a pure atom is inside that reaction, either from the reactant or the product side. Then number B, it says sodium hydroxide plus hydrochloric acid reacting to give us sodium chloride plus water. Now, in any chemical reaction that you see only compound from reactant to product, that is a chemical reaction that contains only compounds from reactant to product side, is not a redox reaction. Any chemical reaction that contains only compounds from reactants to product is not a redox reaction. So if we look at this, sodium hydroxide, hydrochloric acid, sodium chloride, and water. So you see these are only compounds. That means it is not what? It is non-redox. Non-redox. If you look at this, water plus carbon dioxide plus this is only compounds. Then this is non-what? Non-redox. Then what about this? Silver trioxynitrate plus sodium chloride reacting to give us silver chloride plus sodium trioxynitrate. If we look at this, these are only compounds in this chemical reaction, which shows that it is not what? Non-redox. Non-redox. Then, when mercury oxide reacting to give us the pure mercury plus oxygen gas, this is a redox reaction because it contains a pure atom and a pure molecule. Then this is a compound. So this is actually a redox reaction. Then last but not the least, calcium trioxocarbonate reacting to give us calcium oxide plus carbon dioxide. You see that everything here is a compound. That means it's not what? Non-redox. Very good. So those of you preparing for your JAM or WAEC, this question will normally come out. So the easiest way for you to identify redox reaction is by these principles. Now also know that all combustion reactions are redox reaction. What is a combustion reaction? A reaction that has a hydrogen gas reacting with an element or a compound. So this is actually a combustion reaction. So all combustion reactions are redox reaction. And also, you notice that this is a acid-base reaction. This is a base and this is an acid. All acid-base reactions are non-redox reaction. So take note of that, and it will help you. Don't forget to like, share, follow, and comment on our videos. Thank you. See you in the next video.